This question is from the chapter Applications of Derivatives. It was asked in the 2026 CBSE board exam. Take a look at the question. A company produces cylindrical tumblers open at the top. Since they want uniformity in the product, they fix the surface area of the tumblers produced. So this is an AOD question that focuses on minimize and maximize, because if you give a glance through the questions, we need to maximize the volume. In all of these optimization problems, the template is that you have some parameter to either be maximized or minimized, and you will use some given constant to attain that. And this particular parameter that we are maximizing or minimizing, that has to be expressed initially in terms of two variables, and then we convert it into one variable using the given constant. That is almost the template for all of the case study questions. Now on to this question. We'll write the surface area expression. Since it is open at the top, we have only the bottom area covered, which means pi r square plus the curved surface area of the cylinder, which is 2 pi r h. Now look at the optimization parameter. V is the optimization parameter, right? So we need to write volume also side by side. Volume is pi r square h. Now we need volume in terms of the radius. So we don't want h. We have to rewrite the given expression so that we can write h in terms of r. So S is equal to, take pi r common out, so that would be r plus 2h. Now r plus 2h, so that is equal to S divided by pi r, and 2h is equal to S divided by pi r minus r. Now h is equal to 1 divided by 2 times of S by pi r minus r. Take a look at the first question. The first question says volume is V, then V is equal to pi r square h. So radius, retain that, because we need to differentiate volume with respect to the radius. So pi r square, it is initially a two variable function which we are converting it to just one variable function, and it becomes v is equal to pi r square h. In place of h we have 1 divided by 2 times of S divided by pi r minus r. So take this pi r square inside, it becomes S pi r square by 2 pi r minus pi r cube divided by 2, correct? Now if you simplify this expression, it becomes volume is equal to S pi by 2. I think the pi and pi will get cancelled off, so it becomes S pi, rather S by 2 into R minus pi r cube by 2. So what happens? One r on the numerator and denominator gets cancelled, pi and pi gets cancelled, so you're left with this. We are not done yet. This is a 2-mark question. We need to do some more, that is differentiate the volume with respect to radius. So dv by dr, that is equal to S by 2, because differentiation of r is just 1. So S by 2 minus 3 pi r square divided by 2. By this, take 1 by 2 common out, S minus 3 pi r square. This is the first answer. On to the second question now. If the company wants to maximize the volume, so whenever we get these maximize and minimize, we need to find the critical points. We need to equate the first derivative to 0. So in this case also, I'm going to do that. dv by dr is equal to 0. And it becomes 1 by 2 times of S minus 3 pi r square is equal to 0. If you recall, the radius is the only parameter we are retaining in this case, correct? We can find the critical points in case of r is equal to something, but we are not asked that. We are not asked to find the value of the radius that will give you the maximum volume. We don't want that. So what we will do is we'll just write this expression s is equal to 3 pi r square, which means when the volume is maximum, when the volume is maximum, the surface area would be 3 pi r square. You don't have to do the second derivative here unless otherwise asked in the question. Use second derivative to verify this particular result. We don't have to use the second derivative. So s is equal to 3 pi r square. That is an important result we got. And I'm going to bring this old formula of s is equal to pi r square plus 2 pi r h here. So pi r square plus 2 pi r h, that is equal to 3 pi r square. This implies 2 pi r h, that is equal to pi r square goes to the other side, it becomes 2 pi r square. If you cancel 2 pi r on both sides, you will get h is equal to r. Here it indicates that the volume is maximum. We get h is equal to r, and there is one more result, which is s is equal to 3 pi r square. We are not done yet. We need to find what is the volume, what is the maximum volume. The company wants to maximize the volume of each tumbler. One answer we have already done, which is establish a relation between the height and the radius. That we have already done. We're going that extra bit, which is v is equal to what is the maximum possible volume when the h, the height and radius are equal and surface area is equal to 3 pi r square. Remember one thing, in this case the constant is s, which means so pi r square h. So I'm going to write this as r square is equal to s divided by 3 pi. And what is r equal to? R is equal to h, and if you take square root of this, s divided by 3 pi. So volume is equal to pi into r square into h. So that would be almost like r cube. So s divided by 3 pi, the whole power 3 by 2. That is the maximum volume. This question asks for the relation between h and r. This is the required relation. I'm just finding an extra bit of an answer where the volume is, whether it is asked or not, we don't know. So I'm just finding the required answer. So I hope you would have understood this. We'll meet in another video.